Now, let us discuss about the negative of a vector. For vector A, we define the negative of the vector A. That is, we have the vector A, and we want to define the negative of the vector A. By definition, the negative of A is a vector with the same length as A but points in the opposite direction. This is the easiest way to see this is by the graphical way. This is A, okay, and the negative of A is like this, okay. Next, once we have the definition of the negative of vector, we can now define the subtraction of two vectors. When we say R is equal to A minus B, it means that we add A with the negative of B. So if you look at this figure, okay, if we say that C is equal to A minus B, so it means that if C is equal to C is equal to A plus minus B. So we know the definition of minus B. So we can have the subtraction of two vectors. In this figure, you can see that this is A, right, and this is B. Okay, this is A, and this is B. Okay, and this is minus B. So C minus A is equal to not C. A minus B is equal to A plus minus B. So A plus minus B is equal to C. Okay. So that is the definition of the subtraction. Next, we can define the multiplication of a vector and a scalar. If we say that R is equal to A times B, where A is a scalar and B is a vector, it means that R is a vector having the same direction as B and have the length A times that of the vector B. And if we draw the figure, we will have the vector R like this. If this is B, we will have that R is a vector where the length is equal to the A times of B. Okay, so that is a definition of the multiplication of a vector and a scalar. Now, Let us move to an important concept in vector, that is the idea of the component of a vector and unit vectors. We will first look at the two-dimensional vector. For a vector A in two dimensions, the x and y components of A are defined as the vector point along the x and y axis respectively, and we have that the A is equal to the summation of the x component and y component. We can write it down as an equation like this, A is equal to AX plus AY. Okay. In this figure, you can see that once we define the coordinate system, the x axis here and y axis here, and we have the vector A, we can see that these AX and AY are the component of A along the x and y axis, and when we add AX and AY, you can see from this figure that AX plus AY is equal to A. So that is the definition of the component of a vector. From this slide, you can see that it is obvious that if we write down AX and AY, we have that AX is equal to A cos theta and AY is equal to A sin theta. And from this relation, we can see that the sign of components of a vector depend on the quadrant in which the vector is located. Okay. For example, if we look at the x component, if the vector located in this quadrant, AX is positive. If the vector located in this quadrant, AX is negative. If A located in this quadrant, AX is negative, and if A located in this quadrant, AX is positive. And for AY, the vector in this quadrant will have the positive. The vector in this quadrant and this quadrant will have the positive AY. The vector in this quadrant and this quadrant will have a negative AY. Although we have defined the component of a vector in two dimensions, the idea can be straightforward extend to the three-dimensional case. We just include the C direction and use the same definition, that is, in 3D we have that A is equal to AX plus AY plus AC. Okay, and from that we can define the component of A along the X, Y, and Z axis. And for the last topic in this chapter, we will discuss the concept of unit vector. If we have a vector A. If we have a vector A like this, we can define the unit vector along the direction of A and follow. A is equal to the vector A divided by its length. The unit vector along the direction of A is equal to the vector A divided by the length of A. So we will have this vector A. You can see that we use a special symbol, that is, we put the hat above the letter for the unit vector. From this definition, it is obvious that the length of the vector A is equal 1, right? And the dimension of A is equal to 1, 2. The dimension of A is equal to 1, 2. Because from this definition, the dimension of A and of the length of this vector big A will cancel. So the dimension of the unit vector is 1. We can say that the dimension of the unit vector is 1, or the unit vector has no dimension.